Hello everyone, this is KP the Math G here, about to do his 106th YouTube video, all calculus based at that. And so right now we're going to do the 2023 free response question number 5. This is a table of F prime, G, and G prime. We need to learn how to read those tables, and I have done videos on this. This is actually a practice of derivatives, so this will be a good time if you are working on derivatives and the chain rule and so on like that. This will be a good time to do that. If you need some review on this, this is a great review. So I love this. We're going to try to do, I don't know how many of them we will do, probably at the moment A and B, and maybe in another video we'll do C and D. I don't know if I want to do C and separate from D or C and D together, but for the time being we're just going to do A and B. Well, let's get right to it. This says that F and G are twice differentiable. Keep in mind that when you see differentiable, what are you to conclude about the curve? Yeah, in this case, F and G are both differentiable, so F and G are both continuous, aren't they? So, no jumps, no gaps, no vertical tangents or something like that. So they are differentiable, twice differentiable. So that means we can do these derivatives on this. That's really what that's saying here. So let's see. We're given that h at x is given to be f at g at x. Look at that, a composite function. Let me give you an idea of what this is all about. If I were to say, for example, we have, let's say, let's pick something different. G at x is equal to, say, sine of 4x. That is the same thing as f at g at x. If you want to find g prime at x, remember that you're looking for the derivative of sine first. So you take care of this part. So this is f, well, let me make this k at x maybe. Okay, I should have changed that. So let's make this k. Yeah, there we go. Alright, so this is f at g at x, see? Alright, so this is f prime. Alright, like that. Remember, you don't do anything inside here first. Alright, so f at g at x, f prime, g at x, alright, f prime at x, g prime at x, are like that. And then what you do is times what's inside here, g prime at x, which is just 4. Now remember, that is it right here. Let's just say g prime at x. Alright, so what this actually is, it is times 4. So like that. So 4 cosine 4x. Okay, so that's what that's like right there. And so if you have k at, say, pi, then you just simply put pi in there and see what you get there. Okay? Alright, so that's the idea behind this one here. Okay? Alright, so what we're saying here, by definition, this is, so if we want, so we're going to find f prime. So, okay, so we got to take the derivative of this. So h prime at x is going to be F prime at G at X. Do nothing to the G at X at first. And then now times G at X. Alright, so let's see. We want to find H prime at, what is it? 7. So H prime at 7 is F prime, okay, of G at 7 times, G prime, there we go, times G prime at 7. And that's how you do it right there, okay. So now G at 7, what we're looking at is G at 7 is 0. So G at 7 is 0. So in place here we have F prime at 0 times G prime at 7. Alright, so let's see, F prime, there's F prime, find that first, okay. F prime at 0 is 3 halves. G prime at 7, there's G prime at 7 is 8. So 8 right here, put it over 1. 8 goes into 2 4 times. 2 goes into itself 1 time, and 3 times 4 is 12. Okay, like that. Okay, that's where we are right there. And that's the answer. So again, H prime at X, if you got H at X equals F at G at X, it's going to be H prime, it's going to be F prime G at X times the inner part derivative would be G prime at X. So now once you get that, then show this. Don't plug anything in until you do this first. And then plug this in. Remember, do what's inside this parentheses first. So what we did was G at 7. We did G at 7, not G at 2. G at 7 is 0. Okay, alright. Not this here. G at 7 right here. Okay. That's 0. So F prime at 0. And then G prime at X, which we know to be 7. Plugging that in. F prime at 0 is 3 halves. G prime at 7 is 8. So 3 halves times 8 is 12. Okay. And that's all you have to do there. Okay? Alright, so now let's look at the B part of this. I might need to flip the board over. We may have to go back and forth. So let's take a look here. Bear with me as I erase. I don't have anything fancy, just a plain old white board is all I've got here, but that's okay. It does the job. Now let's look at B part. Now it says K prime at X. We're given that K prime at X is equal to, well, let's see, it is F at X in parentheses squared and times G at X times G at X. So we're given that. Alright, so is the graph K concave up or concave down? So we're asking, is the graph, is K concave up or concave down. Alright. And we're looking at when or where x is 4. So where x equals 4. Alright, we need all of that done. Well, we have the first derivative. It's this, isn't it? Now, we're asking the question, or they're asking us the question, is k concave up? That is the graph concave up, or is it down, concave down? Alright. We need to understand what we're looking for. What do we have to do if we're looking for concavity up or concave down? Yeah, you're right. We need the second derivative, don't we? So what we have to do, I'll first of all just find LK double prime at x. That's if now listen. What determines if something is k is concave up while we're at it? Yeah, if this second derivative here, which we're going to find, at x equals 4 is positive, it's concave up, isn't it? But if k double prime at x, whatever that is, at x equals 4 is negative, then k is concave down. That's how you determine it. So, we need to find the derivative of this. Oh my. What? Now, okay, I should have left that there, but I'm going to need some room. So bear with me. We're looking concave up or concave down. So here's what we got to do. Now, I see a product. So I have a product rule, don't I? Product rule is, in this case, the first times, I'm going to put the d derivative of the second plus the second term, that will be this one, times the derivative of the first. Now, one thing about this, you can do it the other way. You can say the derivative of the first times the second plus the derivative of the second times the first. But if you notice, I've got it written backwards. Derivative of the first times the second, derivative of the first times the second, plus the derivative of the second times the first. So go with whatever you want to. Eeny, meeny, miny, mo. Pick one. Alright, well, I'm going to pick the top one. You get the same result either way. I'm not going to show both ways. I'm just going to do one. So it's the first. Here's the first. Alpha at x is squared. Well, okay, alpha at x is squared. Don't forget that. The first. There's your first. Times the derivative of the second. Simple product rule. There we go. Now plus the derivative of the second, or the, let's say the first times the derivative of the second, plus the second, just gonna write that down, right? Times the derivative of the first. Now remember, the derivative of the first is squared. So remember, if I have 3x squared, then the derivative of that is simply going to be 3 times 2 is 6 x to the 1. See? Alright, so you have to, or I could have picked a different problem. Alright, anyway, it doesn't matter. The second times the derivative of the first, that's 2 times L fit x. Now remember, we're raising that up to the 1. That's not a derivative sign, it's just raised to the 1. We don't really need that. Times the function inside, take the derivative of that. But we need to know what it is at x equals 4. So at when x, or where x equals 4. So let's plug this in now. So k double prime at 4 is equal to f at 4 squared times g prime at 4 plus g at 4 times 2 times f at 4 times f prime at 4. So all you're doing now is following this to a T, and you're just plugging these in. So now let's carefully do this. Now remember, we've got to find f at 4 and do what to it? Yeah, square it. Let's put it over here. See if I can make a little room here. Okay. Alright. Remember, we're looking for concave up or concave down. Keep that in mind. Matter of fact, I may just go ahead and erase this. We've already looked at that. Apologize for the inconvenience. So f at 4, where is that? F at 4, be very careful that you find the correct one. F at 4 is 4. So I'm going to put 4. What I'm going to do with that? I'm going to square it. Yeah, that's right. Now, g prime at 4, g prime at 4 is 2. That takes care of this part here. Now I've got a plus sign right here, don't I? Now g at 4 is -3. Ooh, is there a chance that this could be concave down? Well, let's see if this is positive, more positive than this is negative. If it is, then it's concave up. But if this is negative, more negative than this is positive, it's concave down. Okay. Well, let's see. I've got to find f at 4 now. F at 4 is 4. We've already determined that, didn't we? So times 4, okay, times f prime at 4. F prime at 4 is 3, correct? So times 3. Alright, let's see what we got here. 4 squared is 16. 16 times 2. Alright, 3 times 4 is 12, but this is a negative sign. 3 times 4 is 12. 12 times 3 is 36, isn't it? 36. Alright. First times derivative of the second plus the second times the derivative of the first. Okay, yes. This is really a chain rule, isn't it? So let's see what we got. 16 times 2 is 32 plus -36. I get -4. And I don't know, but for some odd reason I recall getting a different answer than that. So let me see, but I think it's correct. Let's see. Oh. I got negative 40 last time. So let me see if I did something incorrectly. Oh, this should have been squared here. Oh, wait, let's see. Wait a minute. I'm trying to figure this out. Okay. The first times the second. I'm good there. Plus, I did it backwards last time. The second times the derivative of the first. So, G at 4 here, and here. Okay. Somehow or another, I'm thinking I did something incorrectly. But let me look at it again. Sorry about that. Alright, but anyway, it does turn out negative, but it's not, in this case, it's negative 4 and not negative 40. Let me see what I've done here. Alright, so when I got this answer, I got this. Okay, so alright, so I got it backwards. I'm so sorry. I apologize. Alright, so the derivative of the first right here, got it, times the second, plus the derivative of the second times the first. Alright. L at 4, 2 times, oh, let me see here then. Alright, so let's see here. So, L at 4, let's double check. Everything's correct. Alright, so L at 4 is 4. 4 squared is 16. Good. Alright. Times G prime at X. G prime at 4 is 2. That's good. Plus, alright, so let's see. G at 4 is negative 3 times 2. Alright, 2 times L at 4. 2 times L at 4. Okay. Alright, so L at 4 is 4, but 2 times that is 8. Alright, and then times F prime at 4 is F prime at 4 is 3. Yes, okay. So 3/8 are 24. I'm so sorry. 3 times 8 is 24. That's negative. 24 times 3. 3 4s are 12. 3 2s are 6. And 1 7. So negative 72. And I got that right. So negative 72. That does make it negative 40. Okay. I knew something was incorrect, but there it is. Then it still would have been negative, but I would have lost a point probably with this arithmetic here. But I got it back. I had the 2 there that I left off. So there it is. Okay, sorry about that. The idea is, though, if this is negative, what can we conclude about concavity? That's the major point we want to get across. Now, I don't know what it is. Old age. I'm just 65, right? You know, surely I'm not forgetting stuff. But anyway, negative 40 is correct. Okay, so now because okay, because you got to have some reason now. K double prime at 4 is negative 40, and negative 40 is negative, then it follows, then K is concave down, where x equals 4. And that's what you really want to say. F double prime is negative 40, F double prime of 4 is negative 40, negative 40 is negative, then K, the function K, is concave down where x is equal to 4. Again, I apologize for this little bit of arithmetic. I knew that didn't look right, and it wasn't right. But now that I've got this is perfectly right now. So the idea still, it would have been negative 4. Well, we would have gotten away with this anyway, but still, we want to get the correct answer here so we can make sure this is all correct. Oh, I apologize for that. But anyway, this is it right here. And your conclusion, you need to write out your conclusion right here. This is vital. Don't just leave it right here. You need to come up with this, because this is negative 4. Negative 40 is negative. F prime at x. Well, I don't know. Let's see. That's I didn't go far enough over. Okay, right there. Then K is concave down where x is equal to 4. Okay, there we go. There we go. Okay, we got it. Okay. Please forgive me for missing that right there. That took up about 10 minutes to figure that out. Okay, anyway, this is KP, the Math G. And of course we had a little practice with some derivatives, okay? The first one was really a chain rule, and the second one was the product rule. I did the product rule correctly. I forgot to put the 2 times in front of that. That made a humongous difference in the answer. So please, just make sure that you're doing everything correct, and do this. Hopefully you won't have to muddle through and like I did, and but anyway, I still would have gotten, just because I had the correct negative, just by chance, it turned out that I could make the correct conclusion. I'd probably still lose a point for getting just negative 4. But now that I got it here, I get all the points there. So again, the product rule, you have a square times something that's not squared. Easy to do, really. It's just the problem was easy. It's just that I made an error in the arithmetic. So please watch that. And even if you had a positive and you said this is concave up, they still would give you the point because you made the correct conclusion on your answer. So they still may give you some credit for this. Okay, make sure you do your derivative correctly. You're going to get some points for that. I don't know how many, but hey, this is what this is all about. So there's a lot of numbers we haven't even talked about 0, and we had 4 and we had 7. I don't even think we did. We might have had 2 in there somewhere, but needless to say, Now you got to learn how to do the graph. Read the graph. G at 0 is 1. G at 2 is 2. G prime at 4 is 2. G prime at 7 is 8. F at 0 is